how we want to do this. We want to actually make or design the 4-bit adder. Using full adder. Okay, so the tools that we have is just full adder. So first, let you actually be what, whenever I say the full 4-bit adder, what actually 4-bit adder means. You probably should know that you use these IC package in our face-to-face lab, right? You tell me, whenever I'm talking about 4-bit adder, how many inputs we have for 4-bit adder. Just type it in our chat box that I see. How many inputs actually has the 4-bit adder? So the 4-bit adder means you actually able to add 2 4-bit numbers plus carry in if just in case if you have, okay? So you use these IC in the lab. So how many inputs we have for 4-bit adder? Yeah, 9, definitely right. So why 9? Because you want to actually add x and y. So the x actually is a number with the 4 inputs, right? So I call this x, which has the 4 bits. You add with the another 4-bit number, which is actually y, okay? And also you want to have one carry in, okay? So what it means this. What is the x? X is this. X is bit. I call that x3, x2, x1, and x0. So what is the y? Y is 4-bit. I actually give a name. Y3, Y2, Y1, and Y0. What we want to do as a 4-bit adder, we want to able to add these two numbers, and even we want to have it is C in. Whenever you have any C in carry input carry, that means you add from these smallest bits that you have, which is 2 power 0. So that means first one should be x0 plus y0 plus C in. So whatever you got, you call that S0, S1, S2, S3. You tell me, whenever you add two numbers which they has 4-bit, how many outputs do we need? Just sorry, type it on the chat box. How many output we should have for this 4-bit adder? 4 is enough, or we need more than 4? So 4 is enough. 4 is enough. Yes or no? 4 is not enough. Why? Because if this is 15 and this is 15, okay, 15 plus 15 is 30. Would you show the 30 with just 4-bit? With the 4 bits, the biggest number you could represent is what? With 4-bit, you have 1, 2, 4, 8. With the 4-bit, the biggest number you could actually represent is 15, right? So if you add these two numbers, for example, if this is 10, this is 6, 10 plus 6, you have 16. Could you represent 16 with 4 bits? The answer is no. You need actually 5 outputs. So that's what we have another one, okay? So I call this S, which is, that should be S0, S1. And the third bits, I call that C4, okay? That means whenever you add x3 plus y3 plus the carry, probably you got this. Probably you actually get one carry, which we call that C4. So this is your C4 here, okay? So you use these IC, right, in the lab. You actually put 4 keys here, 4 keys here, 1 here. You had 9 keys. So then you could actually give the 0, 1, and you connect these 5 to the LEDs, and then you are able to see what's the output is. So you already used that IC, but you had no idea how you could make for these 4-bit adder. But today we will learn how they built that IC. So the answer is using the full adder. So that means I have 4 full adder. This is actually the one. This is full adder. So this is another full adder. This is another full adder. This is another full adder, because what we start with the half adder, right? We made full adder. So right now we know how you could make full adder. Right now we want to combine 4 full adder and able to do this. So you tell me, so you already know the full adder is just has actually 3 inputs, right? So you tell me these 3 inputs should be connected to which of these bits. Just give me a label. What should be connected for the first one? What should be connected to the first one? So back here, what you want to do, you want to do actually add, whenever you add these 2 4 bits number, what is the first things you need to do? You say x0 plus y0 plus c in, right? So that means you need to add 3 bits. Could you actually add 3 bits with 4 adder? The answer is yes. So that means you actually put x0 here, y0 here, and c in here, okay? So whenever you add these 3, what should be the output? The output should be S0, right? So that means the output of this you should have as a S0 that you are looking for, okay? So how about the carry? If I add these 3 together and I got the carry, probably you put the carry here, right? So then for the next, you need to add x1 plus y1 plus the carry that you got from adding these 3 bits, right? So that means you tell me what should be the input of the second full adder. So should be x1. The next should be y1. Could you tell me what should be the third input for the second full adder? It should be the carry that you got from adding these 3. Where is that carry? That carry is here, right? So that means you connect this output of this to this as a third one, okay? So that means you actually made the first one. So now back to here. What should be the next? You need to add x2, y2, and if you have carry whenever you add these 3, also you need to add with this. That means you have 1, 2, 3 bits. You need to add. The answer is S2, the output. So that means the next one should be you connect x2 here, actually y2 here, and the carry that comes from xy plus 1, which is here, right? So you have this. And whatever you have here after you add x1 and y1 definitely should be the output, right? So it should be actually S1, okay? Similar with the others. So the output of this should definitely, you call that S2. And again, for the last one, the carry that comes from x2 plus y2, the carry is here. It should be add with x3 and y3. This is carry, and this is x3, and this is y3. Okay, whatever you got is, you call that S3. You tell me what's the label of these output that we have here? What's the label of this based of the labels that you have here? What we should have here? What should be the label here? Yeah, definitely should be C4. That's right. So that means whatever you got as a carry is the C4 that you have. Okay. So that's it. This is how you could actually use 4 full adder, and you actually made this unit that you see. Okay.